Today we are starting section 9.5. We are going to be spending a few days on it. So today's day 1. Add and subtract rational expressions with like denominators. So far we've already talked about multiplying and dividing rational expressions and just simplifying rational expressions. That's what your quiz was over. So today we'll start the process of adding and subtracting. In our notes today, we just need to revisit some basic fraction rules that you learned, I don't know, probably in 5th grade, if not before. In order to add or subtract fractions, we need a common denominator, a like denominator. And once we have that, so here our denominator is C. If we are adding two fractions together, we add the numerators, but keep the same denominator. The denominator will stay the same as soon as it is a common denominator or a like denominator. So for that example that they gave us for adding the fractions, my denominator is going to stay the same, so it will be a... What's my denominator? 9. My denominator is going to stay a 9. My numerator, I'm going to take what plus what? 2 plus 5, and that would give me 7. So 7 ninths. Do we remember this rule from elementary school, middle school?
Mm-hmm.
Barely. Oh dear. All right, we move on. We've got subtraction, same idea. We will subtract in order that they gave us, so left to right, A minus B in our numerator. The denominator stays the same. So I already heard somebody say it. What's my denominator? A 5 stays the same. In the numerator, I need to take what minus what? 4 minus 1, which gives me 3. Now, on problems that are quite this easy, I would not expect you to have to write the 4 minus 1 step. Okay, but today we might need to write that step because it's not just going to be numbers, we're going to be involving rational expressions. Questions about our basic rules? Now, I'll tell you the nice thing about today is you're already going to have common denominators. You're welcome. But then when we move on, like tomorrow perhaps, they won't be common denominators anymore, and we have to figure out how to handle that. But for today, it should be pretty easy, which is nice since we've got a shortened schedule. Okay. Notes, short and sweet. Rational expressions with common denominators can be done the same way. Which means our denominators will stay the same because they will be common denominators. And we will either be adding or subtracting our numerators, whatever the problem says to do. These start off pretty short and sweet in first couple. On number 1, my denominator is going to be 16. The denominator stays the same because it's common. In my numerator, I'm taking what plus what? 3c plus 5c. What does that give me? 8c. Should it be squared? No, because we're not multiplying. Good point. If we multiply the same variables together, then that's when the exponent changes. But if we're just combining like terms, which is all we're doing if we're adding and subtracting, combining like terms, we do not change the exponent. Do we think this is our final answer? No, why not? We can simplify it. So we would divide both the top and the bottom by 8. So our numerator turns into C over 2. If you want to put a 1 in front of your C, you can. 1c over 2 if we simplify that fraction. Questions about how this works? Okay, number 2, what is my denominator? 4. In my numerator, what am I doing?
Subtracting 5 minus 3.
Good, subtracting 5x minus 3x, which gives me?
2. And then 2x over 4.
Okay, so let's do it one step at a time. 2x over 4. Can we reduce that? Yes, but now when we reduce, our denominator is going to change. So we end up with x over 2. So when we do the adding or subtracting step, we're keeping our denominator. But if you end up simplifying, then your denominator would change. If you have to simplify the numerator, it's got to simplify with the denominator at the same time. All right, I'm going to write some of my work for number 3 above the problem just because I want to show a little bit on this one. What will my denominator be?
9.
A 9. And in my numerator, what am I doing? Subtracting.
Subtracting 4y minus 3y.
Careful. We're subtracting 4y minus this whole quantity. Remember, if we have a binomial in a numerator like that, it's kind of trapped together in parentheses. So that's how I would recommend writing any sort of binomials or polynomials, especially if it's a subtraction problem. Because this minus sign is not only going to change the sign on the 3y, it's also going to change the sign on the 1 in the back. Does that make sense? We have to distribute a negative when we're subtracting a binomial. So this turns into 4y minus 3y plus 1 when we drop those parentheses. This is one of the only ways that today's lesson is a little bit tricky because we've got to be careful about subtracting binomials. When you're adding, it's fine. Your signs aren't changing when you add. But subtracting is where we could get messed up. Now we can combine like terms. And what do we get in the numerator?
1y plus 1 over
Good. 1y plus 1, still denominator of 9. Can we simplify that at all? No. There's nothing that we could cancel out, nothing we could factor, so we leave it alone. Questions about number 3? Okay. So on number 4, same idea. My denominator is a 10. And my numerator, I have 5x plus 4. I'm not going to worry about putting that one in parentheses because there's nothing out in front of it. But I'm subtracting the other binomial. So I will put it in parentheses since we've got a minus sign right out in front of it. So we still have a denominator of 10. This becomes 5x plus 4, and then what would come after it?
negative 3x plus 8.
Good, minus 3x plus 8. All right, we move on to simplify. So we are going to combine our like terms. What can be combined? 5x and 3x. So what would that give me?
2x.
Good. We're subtracting, so 2x.
Plus 11.
Okay, plus 12. Now comes the question, do we think we're done with this one? No, we can simplify it more. What can I factor out of the numerator? A 2. I'm going to run myself out of space. 2 times what? X plus 6 all over. Not yet. Right now it's a 10. And then we would reduce the 2 and the 10. So the 2 becomes a it goes away, or it can become a 1, and the 10 becomes a 5. So our final answer for number 4, I don't have any great place to put it, so I'm going to bring it all the way up to the top. Final answer would be x plus 6 over 5. If you want to drop the parentheses, you can, because again, there's nothing out in front of them now. That would be our answer for number 4. All right, on number 5, I'm just going to go ahead and take away 7 and 8 for a minute. If you still need those, they'll come back. Number 5, my denominator is going to stay, for now at least, 8. I have to take my first numerator, 6t minus 1. What operation am I doing this time? Subtracting. So I'm going to use parentheses on my second numerator. So minus parentheses 5t minus 4. When I go to get rid of those parentheses, I am essentially distributing that negative into the parentheses. So I have 6t minus 1 minus 5t plus 4. Signs change in the second set. All of this is getting divided by 8. Okay, then we go to combine like terms in the numerator. So the 6t gets combined with the negative 5t. That gives me 1t. Positive or negative? Positive, because the 6 is bigger and it is positive. Then we also have to combine what? Negative 1 plus 4 gives me positive 3, so I put a plus 3. Is there any way that I could simplify this more? No, there's nothing to factor. Nothing's canceling out, so we just leave it there. Questions about 5? Okay, on number 6, what is my denominator, at least for now? Y minus 5. So I take my first numerator, y minus 2. I'm using this big old subtraction sign from the middle. So for my second binomial, I'll go ahead and put it in parentheses. 3y plus 1. We okay with that? To drop those parentheses, we have to distribute the negative. So 4y minus 2 minus 3y minus 1. Good. My denominator is still y minus 5. That has not changed. So we go to combine like terms in the numerator, which means we still, at least for now, have a y minus 5 in the denominator. What am I combining in my numerator? 4y minus 3y gives me 1y. And then I also can combine negative 2 minus 1 gives me negative 3. So then can I cross off those y's?
Yes.
No, you cannot. Just like the last few lessons that we were doing, those you have to treat as if they're trapped together. So if you want to put parentheses back around your binomials, you can. Do not cancel those out. Just because we're moving on to a slightly different topic, that rule is going to stay the same. If it's part of a binomial, you can't break it apart to cancel it out unless you factor it. And those cannot be factored, so that is our answer. Are we okay with that rule?
Yes.
Some of you made me a little nervous by telling me I could cross those off. Charles.
I didn't see the parentheses.
Well, that's because you don't have to write them, so they won't always be there. You still have to know. Imagine those invisible parentheses trapping your binomials together. All right. On to number 7. What's different about 7 from some of the ones we've done?
What's has a power?
It has
Yeah, so in the denominator, we've got a variable that's got an exponent on it. That's different. What else?
There's two variables.
There's two variables. Also, we're going back to what operation? Addition. So make sure you're watching what operation they're telling you to use. Don't just get on a roll and treat all of them the same. Now, what will stay the same, at least for now, is my denominator. 12y to the fourth. Might not be the prettiest denominator, but it's going to stay the same for now. In my numerator, I'm taking x plus 3y plus x minus 4y. If you really want to, you can put parentheses around your second binomial like we've been doing. However, distributing a positive to those does not change their sign. So if it's an addition problem, we don't have to use those parentheses. We can go straight to now combining like terms. My denominator stays the same. In my numerator, what can I combine? X plus x is 2x. What else? Okay, the 3y and the negative 4y combine to give me minus y. Is there anything that I can do to simplify this more?
Yes. The y. 2 and 12 and then y. And y to the 4.
Am I allowed to do that?
Oh, no.
No, this is a binomial that is trapped together, so we cannot pick and choose what we cancel out. Don't fall into that trap just because we've changed what type of problem we're doing slightly. It's still a rule. So the only way that we would have been able to simplify anything is if we could have factored the numerator. Can we factor that numerator? No. There's no GCF, no way to change it. So this is our final answer, whether or not we use those parentheses in our numerator. Okay, you're making me a little nervous.
I was just testing your skills.
Uh-huh. Are we ready for 8?
Yes.
Okay. On number 8, my numerator for now, or sorry, not numerator, denominator for now. 9b. In my numerator, I have a plus 5b. What operation did they tell me to use? Addition, so plus a minus 3b. Are any signs changing this time? No, because it's an addition problem, so we do not worry about changing signs. My denominator for now is still 9b. In my numerator, I need to combine like terms. The a's combine to give me 2a. What else?
5 minus 3 is 2b.
Okay, plus or minus 2b.
Plus.
Plus, the 5 is bigger, it is positive, so this would be plus 2b. Is there anything else I can do here?
No.
Factor! We can factor this. What factors in my numerator? A 2, I'm going to go above, 2 times what? A plus b. My denominator is a monomial, so it is not factoring. So can I simplify anything? No. So this is my answer for number 8. Now, if instead of a 9b, we'd had an 8b or a 10b or any even number b, then we could have reduced with the 2. But since it's not an even number, it will not reduce with the 2. Questions, concerns? Ready for more examples? Okay, number 9 and 10 are a little bit tricky, so we will talk about those together right away. Get at least number 9 copied down real quick. Let's see how number 9 goes, and then perhaps What do we notice about these?
The
There's
numerator
no-
is
Do our denominators match?
No.
No, but are they close?
Yes.
Yes. The only thing we really need to change about our second denominator is what?
A negative 1x.
The signs, right? Yeah, we want this negative x to be a positive x. We want this positive 3 to be a negative 3.
We multiply by -1.
Not multiply it, but divide it. So we're going to factor out a negative 1 from the denominator. Or you could think about it as multiplying. If you like the multiplying idea, that's fine. But if we are going to keep this even, we are going to have to multiply this fraction by the same thing on top and bottom. So if you want to think about it as multiplying, that might be a better idea for some of us. If you still want to think about it as dividing, it's the same thing. If you do something to a denominator, you have to do the same thing to a numerator. Otherwise, you're changing the fraction. This is just coming up with an equivalent fraction. So for now, my first fraction's not changing. That's the one that we want our denominator to match. I'm also not changing this from being an addition problem. Still adding. If I multiply 7 times -1, what do I get? -7 over. Good, so this really is -3 plus x, but I want to rearrange it, so I'm going to rewrite it flipped around where I switch these. So it would be positive x minus 3. Are we okay with that?
Yes.
Do we have questions? This is kind of the weird piece about today, is getting those denominators to match by using a negative. Now that our denominators match, this should be a pretty easy problem to finish. My denominator is
x minus 3.
x minus 3. My numerator, I've got 2 plus -7. What does that give me? -5. Okay, go ahead and try number 10. Use the same idea that we used on number 9. We'll talk about it in just a moment. Number 10, we want those denominators to match exactly. So I need to switch the signs on my second denominator. In order to do that, I could multiply by a -1, but to keep the fraction even, I also have to do that in my numerator. Okay. So we've got the same first fraction, same exact one, keeping that minus sign. Now, when I multiply by a -1 on the top and the bottom, my denominator changes to match. Now, if you need to rewrite this off to the side as a -5 plus n and then flip-flop it, that's fine. But hopefully after a couple of these, you can see that you can just go straight to the n minus 5. What do I need to be careful about in my numerator?
Everything changes.
Everything changes in my numerator also. So this becomes -4n minus 9. Charles?
So the -1 just keep it the same, the minus sign.
So let's talk about it. So now, when we go to put these together, we are subtracting. So that means we are going to then have to distribute another negative. So Charles kind of already figured it out. That's going to flip these signs back to what they were initially. So that means we've got 6n plus 3 plus 4n plus 9. Still same denominator. So yes, they had to change once and then they had to change back. So if you want, I don't know that I would recommend this because sometimes we get a little, a little too excited when we skip steps here. But if you change this to an addition problem, when you multiply top and bottom by a negative, that's kind of a shortcut. I don't know that I would recommend that because some people will then end up changing some signs and not the right signs. But this shows you how that kind of works out. Okay, now let's go ahead and get some space up here so we can actually write an answer. For now, my denominator is going to be that n minus 5. In my numerator, 10n plus 12. What should I do now? Factor out a GCF. What's my GCF? 2 times 5n plus 6 all over n minus 5. So after I factored, nothing canceled, but it's good that we factored it to show that that is definitely our final answer. Questions, concerns? Okay, we might revisit some of these other problems tomorrow, but this is where I'm going to stop our video.